Good evening, everyone. Thanks for joining the webinar on program and simulate your industrial robots to reduce your ramp-up time and costs. And thanks for sharing your spending your valuable time here. We have Mr. Kanwajit, who is a Delmia specialist and brand leader from Dassault Systems, and Mr. Sundar Ramurthy, who is a application specialist Delmia from EDS Technologies. Mr. Kanwajit will give you the brief introduction about Delmia and what is its challenges that are faced in the industry and how the Delmia product can overcome these challenges. Mr. Kanwajit, over to you. Hello.
Yeah, can you hear me?
Yeah.
Okay, so I will just speak on and then I will let Sundar to continue. I will just give a very brief intro about the Delmia. So I'm not presenting anything, I'm just giving you a very brief overview. First of all, thank you all of you for coming and showing interest in the session. Though this session is more focused on the robotics side, I will just give you a brief overview on Delmia. Delmia basically stands for Digital Enterprise Lean Manufacturing Interactive Systems. What it does, it basically covers everything related to manufacturing. We have a lot of brands, different brands in Dassault Systems, like for example CATIA for design, Simulia for physics-based simulation or FEA analysis, Innovia as a PLM backbone, and then Delmia is something which covers everything related to manufacturing processes. So once you have designed a product, let's say, and you want to, and you have even validated it from the CAE perspective, and then you want to manufacture it and not doing things from process planning to any validations or simulations, alternative studies, digital factories. So everything that you do as part of planning, including machining, robotics, simulation programming and all, to the execution on the shop floor, where we can connect even with the real time in the shop floor with the machines and fill the space between the shop floor and the enterprise systems, where that provides you a complete visibility of the plant and help you to synchronize with the ERP systems or PLM systems to have a kind of a connected manufacturing and the execution of manufacturing on the shop floor. So Delmia typically covers the entire range from the conceptual or the planning stage to the execution, and then connect back to the design or to the process planning tools. So so this is just to give you a very brief overview. I will let Sundar now to continue with the robotics, and for any questions you may have, I would be glad to answer. Yeah, please Sundar, go ahead.
Yeah, thank you. Thank you, Kanwajit. Good evening, everyone. So this is Sundar Murthy. I'm taking care of Delmia from EDS Technologies. I'm having 5 years of experience in this field with the robotics and human ergonomics and assembly simulations in the various industry domain. I just want to quickly go through our company presentations. So we are the EDS Technologies. We have a PLM and visual simulation solutions, and with the different type of customers and taking their own project ownership to deliver with a timely and with a cost-effective of cost manner. So we are the 22 years old company. Then we have a multiple location, like 13 locations, and we have 200 plus employees over there in EDS technologies, and we have a big customer portfolio things and around 1,500 plus customers we are there. Then we have a world-class training which we are providing for Autodesk and Dassault. We are the certified partner education partner for these two softwares, and we have a different kind of verticals like we are into the PLM and mining and visual simulation. When you are coming into the enterprise solution, we are handling the SAP also. Then we are doing the services implementation of CAD/CAM and SAP implementation and Innovia implementation. So and we have a certain different vertical of industries. It's starting from automotive, electronics, aerospace, and energy process utilities companies, and tooling, manufacturing, and packaging. So we are into the mostly all areas of industries verticals. So this is we have a milestone of our ADS portfolio. We started the company in 1996, and then we have partnered with the Dassault system, and we have received the many award of the year and the Platinum Club Excellence Award from the Dassault system portfolio. And these are all the Dassault system portfolio where we are selling and doing the servicing into the CATIA for the product design, and Innovia for this PLM lifecycle management, and Delmia is for the digital manufacturing simulations, and Similia for the analysis. XL8 is for the search-based application. Then 3D you can create and share your experience, communication, technical publication, and all those things we can do it. So and we have a recently 3D experience. It's a single unique platform where you can do all kind of activities. You can do it here. The 3D apps, it's for the CATIA design related apps, and VR, it's a virtual and reality labs. Apps is for like Delmia and Similia. So this is the it's giving the customers experience with the delightful things. And we have a strategic partners with the Dassault system, SAP, and the Human Solution, and Transcat, VTMAC, Pegasus, and Ziva, and Netlink. So this is what our overview of our company presentation. So I'll go with this Delmia Robotics solutions in upcoming slides. Okay. So what we are going to cover is we are into the digital manufacturing. We are going to program and simulate our robots and reduce the production and ramp up time, and the cost also. So how we are going to achieve these two scenarios with the using of our existing Delmia software. So before going into this Delmia, I just want to quickly tell about what is digital manufacturing. So it is a simple answer. It's saying that what I'm going to produce, how and where I'm going to produce, and how to optimize my production. So in right now industrial scenario, so if I'm going to make create a one product or any other device thing, so from where I have to start. So what is the process and what is the resources involving and how much time it has taken. So all kind of process planning we can do it with the digital manufacturing. And once you have done all the studies, and we can optimize our production. So if I want to increase my production, what I can do my level best. So we can create like a multiple of what if scenarios, and we can derive the best scenarios to optimize our production. So what I can foresee and I am empowered, that is the answer for this digital manufacturing. So the digital manufacturing is covering the following of the areas started from the process definition, process planning, and simulation of operations. Like a simulation in the sense you can digitally see how my factory is going. So our factory will have a multiple of robots and mechanical devices and machines or human things will be involving. So how all the resources will be working and how my factory will be running. So digitally we can validate if it is the error when the robot is moving from one place to another place, or when it is clashing with any car panel or fixture and or gripper. So we can validate it before when it is going to production. So that's why it's called a digital manufacturing. You can see how my shop floor will be running by the digitally. So apart from this, we have a time study analysis, ergonomic analysis, where you can do your ergonomic study where the motions, and you can see the analysis whether my mannequin will be do the particular activity or not. So all kind of studies we can do it here. And you can see now the traditional methodology, what we are doing is we are doing with the all physical validation. So we can validate, we can create a prototype and we can validate. So what will happen because of this traditional methodology, our cost will be getting increased and my sort of production also will be getting delayed. So when we are moving into this digital manufacturing, everything we are validated by virtually before going into the production. So what will happen, my cost will be coming down and my startup of production also it is coming before. So this is why we are moving into this digital manufacturing world. So when you are coming into Delmia, Delmia we have an abbreviation called Digital Enterprise Lean Manufacturing Interactive Applications. So whether lean manufacturing is nothing but you can avoid all the wastages. So it is allowing manufacturer and suppliers to create the plan and monitor that plan and control all the production process from the earlier stage. That's nothing but my planning stage to the assembly stage and the robot wise and cell wise, and from the robot cell we can create a programming, and that programming we can validate with the real-time robot. So it is starting from the end, start to end. It will be covering all the areas. So because of this Delmia software, we can get a maximum production efficiency and the lower cost, improve our quality and reduce the time to market. So these are all the benefits from our Delmia software. So I'm going with the robotic solution today. So why our robotic solution is involved? So we can create our program for our robot and we can validate that robot program with the virtual real-time robot. Because of this, what will happen? Our capital investment of the designing of the new product will be getting reduced, and we can validate our own robotic cell. So in what will happen, the company having a robot and all the cells. So if you are not using like a digital software like Delmia, so if you are not validating, what will happen? Our planning will not be proper. So what we are doing is before going into the production, we are placing our robot and fixtures, everything, and we are validating those applications with our robot. Because of this, we can avoid that error and increase our manufacturing volume and reducing the cycle time. That is one important thing. So next one is what we have with the robotics. We are having a spot welding operations and arc welding, material handling, so painting. So these are all the areas where Delmia Robotics is performing. So what is the use of industrial robots? Where it is using for this material handling devices, where you can pick and drop the product from one location to other location with the use of gripper, and you can use for the welding of the robots. With the help of robots, you can do the welding. It's called arc welding and spot welding, and even now this additive manufacturing also we are using the robot. So mostly in almost all the industries we are having a robot. So the robot is mainly working important key player in the nowadays in the shop floor. So what kind of industrial robots we have it? So we are having a rectilinear and articulating robots, where the rectilinear robots is only for the X, Y, Z for the 3 axis, and the articulating robots, it's like working like as our human arm. So it is having a rotating joints of 6 axis. So mostly in almost all the automotive industry are using the articulating robots for the above the activities which we discussed earlier, like arc welding, spot welding. So those kind of activity mostly articulating robots are involved in. And why robotics welding is necessary. So nowadays the manual welding will be lead time will be taking more, and even the error will become error time, sometimes error also will be there, and quality of the weld will be very low. So in order to avoid things, so what we are using is we are using the robotic welding. So the main application for this robotic welding is no breakdown in the production. So like when human welding, so the mannequin will go for the break or any other things, he will be going out from the cell. So in order to avoid, when we are using the robot, there is no break, and faster the welding cycle time, and the quality of weld will be the good. The wastage of material will be avoiding, and so some of the hazardous places and all, we are removing the worker from that locations, and it will be a more precision and flexibility, and saving the money also to the company. So in the traditional method of simulation, what we are doing it will be starting from the CAD data. The CAD data will be sent to the external vendor for the simulation, and that vendor will be simulate the robotic cell and reachability study and collision analysis, and optimal performance is nothing but the optimization of the layout. That guy can move the robot, and he can tell, okay, in this particular places my robot can achieve the work. So those kind of studies he will be doing. Then again generate the offline programming and send it to the specific vendor robot controller. Then robot operator upload the OLP, that's offline programming, to the robot controller and run the program and validate it. If anything error it's there, then they are sending back to the CAD system, and again redesign and revalidate everything they are doing with the and regenerate the OLP. This is a traditional method. When we are doing it, what are all the area we are getting a problem, in the sense that data transfer from the vendor so company to the vendor, it is different. So vendor specific format, it is not happening. Then the different UI is there, and there is no change management also. Then there is no different solution for the different robot vendor. Like ABB is having some other solution, and Fanuc is having some other solution. So where we are having the problem. So how we are Delmia is avoiding, in the sense we have a inbuilt robot library where you have all kind of robots. So you need not to worry about the vendor specific robot. So we have a ABB, Fanuc, and almost all the robot library with our uh, Dassault system. So we can do the validation, and we can create a programming and validating everything. Then we are sending to the end customer. So where we are having everything in integrated solutions, where we are doing all the simulation, OLP, and everything will be in the single platform. So how we are improving your productivity using the virtual simulation? So as I told, we have 1,500 plus industrial robot with 15 robot vendors is there, and we can validate our work cell and design before going into the production. And we are simulating your robot with again with a weld gun and arc. If it is arc welding, we have arc welder. So and optimize our work. So in order to achieve like a cycle time and all those things, we can validate our work cell with a different scenario, and we can suggest the best scenario uh, to the customer, and we can run the create the robot programs by offline. That we have a OLP module, we have it, and multi-robot and cooperative and collaborative scenario also we can manage it up. So what benefits from here, in the sense we are reusing the existing tools and programming for again the improver of our productivity, and the meet the cycle time requirements. It's again important one. So and we are the one more most important thing is we are identify the problem in early the programming phase itself. So what we are going to do, we are validating the cell. If we are finding out if there is any problem in the cell. So we are just redesign that particular jigs or fixtures or gripper, and we are validating again. So what will happen in the design level itself, we are validating everything and avoiding all the errors. Then one more thing is what optimizations of our layout and material flow. So layout optimization is that to when we have a scenarios to design the optimum layout, and it will be reducing the material handling cost and improve your throughput, minimize the space requirements, and lower the energy bills. So material handling cost, in the sense, if I'm using a 5 robots in my work cell, if I just want to validate it using our digital manufacturing software, I can validate and I can derive it. Okay, instead of 5 robots, I can use it within the 4 robots. What will happen on our material costing, handling cost will be reduced, and we can improve our throughput, saying that we can uh, uh, make sure that work cells and all will be very near and within a reachable area, so that our throughput analysis can be achieved, and even the space requirement also we can do it off. So these are all the benefit when we are doing the digital manufacturing in the optimization of the layout. So what is the value in the sense? Reduce the equipment cost, yes, and optimize our workforce and simplify the planning. So what happened, instead of 5 robots, I'm using the 4 robots. So one robot working, I'm avoiding it, and I can detect the bottleneck. Okay, where I will getting a pain, in which area I'm getting a pain. Okay, how to avoid this pain? So in order to avoid that pain, what and all I can suggest? Okay, I can add one more labor there, or I can add one more material handling device. So these kind of things we can do it up and validate our manufacturing process. So this is a one case study for the multiple robots working together with the different kinematics devices. So you can see here, this is a work cell where the robot is performing with the multiple, how the multiple robot is performing in a single line. So the robot is taking a car panel from one location to another location, and the other robots are doing the spot welding operations. So, so this kind of uh, working will be achieved from the, we have a IO mapping. So when the IO mapping, if we are go through it, so it will be giving the clear-cut idea. So when the robot, one particular robot is working, the other robot, it has to be stopped. Then the particular robot gives signal to the next robot. So this kind of performance we can do it when we are using the multiple of robots like this. So we have a mechanical device behavior workbench, so where you can create your own kinematic device, and you can give the conditions like if in the gripper or fixture there will be a open and close conditions will be there. So you can give within this limit my open should happen, then semi-open we can create it. So those particular kinematic devices you can use when you are doing the simulation of the robotic. So what will happen, you can see the this particular clamp will be open and closed when the gripper will come. So these also you can in the simulation you can validate your kinematic device also. So whether my kinematic device, when it is open, whether it is clashing with our car panel or any other devices. So if it is a clashing, so okay, how I will avoid this particular clash? Okay, either I can change my design or I can change my angle. So this kind of validation we can go through it. So we have a one customer showcase stage for this Delmia V6. So, okay, this is a Centerline Windsor Limited video. Their headquarters in Canada, and 550 employees over there. And they are using the Delmia V6. So they are doing the validation with the fixture and gripper, and they are doing for the arc welding also. So they are validating the cell in the design level itself with the different of robots. So what they are doing is they are validating their like a fixture and jigs with a simulation. So they are avoiding the cost issue and cycle time and the flow space. That is nothing but our optimization of the layout. So using this Delmia V6, they are reducing the cost and uh, time to delivery they are achieving. Yeah, see how that Delmia will be help on there. They have a 50 robots in their line. Actually, they are validating with the Delmia V6 for the their design for the fixtures and jigsaws. And customer likes that mechanical device behavior. Uh, there you can create like conditions with the different. So it's like yeah. And they are users of arc welding also. The weld angle of the arc welding, they are changing it and checking whether it's clashing with the part or not. So validating, they are doing it. So what they are doing is they are getting a save timing and they are getting a more efficiency from this software. So apart from this, we have a spot welding of robots where you can have a servo guns and you can again validate the spot whether can achieve it or not with the spot welding application. So if the customer is having a multiple of a gun, weld gun for the spot welding, so you can search, you can take a multiple of gun and with the selected the spot whether which weld gun will be feasible for this particular or setup of weld points. So what will happen? You can uh, we can do the robot placement also along with this weld gun, and we can validate it whether my this weld gun is having a collision with the car panel or not, or so this kind of validation we can do it, and where we are selecting the right robot and right weld gun in the initial level itself. So you need not to waste the time for that particular activities. So in order to avoid this, we are having a spot welding application. You can validate it with the application, and we have a arc welding also, where you can create your arc with a simple clicking of like a two arc if you are selecting, or two lines if you are intersection line if you are selecting. My arc will be creating automatically. Then I can create my robot path for that particular arc area, and I can position the tool, and I can check it whether is the class is there or what while doing this simulation. And the final thing is what we have a OLP things also. So whatever we are doing, creating the program in the Delmia, so that program we have to download with the real-time robot as per the robot control norms. So we have a different robot controller like ABB, Fanuc, Hitachi, Kuka. So kind of like different robot controller is there. So the robot controller, what will happen? It will be downloading the robot program from the Delmia. So this robot program we can upload into the real-time robot. So that real-time robot, what will happen? It will be performing how the virtual robot is performing. Like in Delmia, however the robot is performing the same kind of way in real time also the robot is performing. So we are avoiding the repeated work and class detection in area stage, which we are using the Delmia software. So we have one more video for this robotic simulation of offline programming. Yes, thank you. So we have a RRS where the you can use the RRS technology for the virtual robot with the validating with the real-time robot with we can use the simulate and with the NRL, so it's called a native robot language, and we can program our robot simulation with the virtual teach content. So by using virtually we can validate how my real-time robot will be performing using the RRS. So it will be giving the accuracy motion, how like 98% of accuracy you will get it with how the real-time robot it's working. So like that you will get it like in virtually. So we have one more case study with the future link factories of Locomotive. So Protax Locomox is a company for the company, they're Airbing manufacturing company, and they are using our 3D Experience Delmia V6 portfolio. 3D Experience portfolio for the starting from the assembly and the validation of the robot, then human ergonomics validations also will be involving, and up to drilling and riveting with the robotics. So they use almost all the modules of our Delmia. Then we have some good customer case study with us, with the Tesla Motors. They are the users of Delmia V6, and they achieved reduce the cost of the develop product of Model S. They initially did the pilot project, and then they executed the same thing with the Model S. And one more is the ADAC light vehicle car also. They are the users of Delmia V5 and V6 for their manufacturing cell and robot simulation, and they are users of they are using the line balancing for that cell. And the one more big automotive giant, JLR, they are also users of Delmia V6. They are validating their factory 3D digitally using our Delmia software, and they are doing the layout optimization of their operations, and resources optimizations also they are doing. And finally, that ultimate goal of that their robotic cell also they are validating with the use of Delmia V6. Yeah, that's all from my side.